Welcome to Chapter 5. Today's learning target is to find the least common multiple. In your notes, let's start off with the definition of multiple. A multiple is a number is the product of that number and any non-zero whole numbers. Below is an example of multiples. The multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36. The multiples of 6 are 6, 12, 18, 24, 30, 36, and 42. You will see that there are some common multiples. My common multiples are 12, 24, 36. They're in common to both lists. Pause the video if you need more time to get the notes. The least common multiple is the multiple or the smallest multiple two or more numbers have in common. So in my list, I would pick out of multiples in 4 and 6, I would choose the number in both lists that is the smallest. In this case, the least common multiple is 12. There are two methods that you will learn to calculating or finding the least common multiple. The first method is to make a list of all of the multiples and find the smallest. The second method is to make a factor tree for each and multiply the largest power of each factor. For example, a factor tree for 4 is 2 times 2, or 2 squared. A factor tree for 6 is 2 times 3. The least common multiple, when I look at these, I have a 2 squared and a 2. 2 squared is the largest power of that factor. It's bigger than 2 to the first. And then 3 is by itself. There is no other factor that is bigger. So 2 squared times 3. 2 squared is 4. 4 times 3 is 12. Let's practice first making a list of multiples, and then we'll try the other method. So finding the least common multiple of 3 times 4. Not 3 times 4, 3 and 4. The list of multiples for 3 are 3, 6, 9, 12, and 15. The multiples for 4 are 4, 8, and 12. The least common multiple, when I look at the two lists of numbers, is 12. Some of you might notice a pattern. The pattern you might start to notice is that if there is no common factors between 3 and 4, you can simply multiply the two numbers together. That is indeed a pattern that will hold true for all numbers. Pause the video, try B and C, and come on back to compare your answers to mine. For letter B, the least common multiple is 20. This one is terrible. For letter C, you can list all these multiples and you never get there, right? But some of you might have noticed that there are no common factors between 3, 4, and 5, and that means you can multiply them together. Or you kept going with your list and you found that the least common multiple is 60. What this really shows us in letter C is that there really is a use for a second strategy for finding the least common multiple, and that's where the factor tree comes in. Today, both school baseball and school soccer teams had games. The baseball team plays every 6 days, and the soccer team plays every 5 days. When will both teams have games on the same day? Well, I can see that I need to write down the multiples of 6 and the multiples of 5. The first time that there is an overlap is on day 30. Let's try the second method or the second strategy of using prime factorization to find the least common multiple. The first thing you need to do is make a factor tree of both 12 and 40. 12 is 3 times 4, 4 is 2 times 2, so the prime factorization is 2 squared times 3. To make a factor tree of 40, I wrote down 10 times 4, and then I broke those down into 2 times 5 and 2 times 2. Prime factorization is 2 to the third times 5. To find the least common multiple, as a review, it says to make a factor tree for each number and multiply the largest power of each factor. So, what is the largest power of the factor 2? 2 to the second or 2 to the third? Well, 2 to the third is bigger, so 2 to the third is what I write down. Then I've got the factor of 3. Whoops, I just scribbled it out. 3 is by itself, so 3 is the factor I'll use. So put a 3 down. Then I have a factor of 5. 5 stands alone, so it is the biggest. So I write down 5. 2 to the third is 8. 8 times 3 is 24. 24 times 5 is 120. And so my least common multiple is 120. Notice that 12 and 40, both have factors in common, so I can't just multiply those two numbers together. You'll get the wrong answer. You'll get a common factor, but it won't be the least common factor. Least common multiple. Jeepers. All right, so give these to pause the video. Try B and C. You can cross out letter A, and then come on back to compare your answer to mine. Oops. All right, for letter B, when I look at common factors, I want to pick the largest of the factors. So 3 and 3 squared. 3 squared is the bigger one. And then there's a 5 and nothing else. So 5 is the biggest. So I would say the least common multiple is 3 squared times 5. 3 squared is 9. 9 times 5 is 45. The same process works for 3 numbers. I pick the largest factors of each base between all 3 numbers. So in the first one, 12 is 12 squared times 3, 15 is 3 times 5, 18 is 2 times 3 squared. 2, I have a 2 squared and a 2. 2 squared is bigger. I have a 3, and a 3 squared. 3 squared is bigger. I have a lone 5. 5 is alone, 5 is the biggest. So I multiply those largest factors together. 2 squared is 4. 4 times 9 is 36. 36 times 5 is 180. The least common multiple of the 3 numbers given. Now, it doesn't end there. The whole purpose of what we do in 7th grade is to take what we learned in 6th grade and add both negative numbers and variables. In this case, variables. So the process you're going to see is very similar to what we just did. So you're going to make a factor tree of 6a squared and a factor tree of 18a cubed. Again, notice I used squared and cubed. And so what you're going to do is 2 times 3 times a squared. Notice I just brought the variable down. Then I do 2 times 3 squared times a cubed. I just brought the a to the 3rd power down. The least common multiple, when I look at the largest of each factor, so I have 2 and 2. I have 3 and 3 squared. I have a squared and a to the 3rd. So now I multiply those together. 2 times 3 squared times a to the 3rd is 2 times a squared is 9, so that's 18 a to the 3rd is my least common multiple. See how I used and applied the biggest exponent works even to variables because variables are numbers. Now I'd like you to pause the video and do B and C in the next box on your notes paper. Oops, looks like I didn't cover up the answer for you. There we go. Try these 2. You can cross out A, and then come on back to compare your answer to mine. All right, for this one, hopefully you got the same answers for the prime factorization. The largest of 2 to the 3rd is 2 to the 3rd. So write 2 to the 3rd down. Then the next one is 7. Then I've got m to the second and m to the fourth. And m to the fourth is the biggest. 2 to the third is 8. 8 times 7 is 56 m to the fourth. The last one, 5 squared y squared is the same as 25y squared. 3 times 5x is the same as 15x. When I look at the largest base of each, the largest factor, with each base, I've got 5 squared and 5. 5 squared is the largest. I've got 3 and no other 3, so 3 to the first is largest. I've got 1x and no other x to compare it to, so x is the largest. I've got y squared and no other y, so y squared is the largest. Then I multiply each of these largest factors together. 3 times 5 squared. 5 squared is 25 times 3 is 75 xy squared. All right, let's give your homework a try. It's found on page 229.